It's pretty amazing when you think about it. Your body, it's like this super advanced machine, right? Every single move you make, from a tiny step to a huge jump, follows a whole set of complex rules. So today, we're going to do something cool. We're going to crack open the user manual and take a look at the physics engine that makes it all run. Let's dive in.
So here's what we've got on tap. We're starting with the big picture, the science of movement. Then we'll get into how physics actually works on our bodies. We'll talk about the why versus the how of it all, learn some of the lingo anatomy uses, and then wrap it up by looking at the body's 3D blueprint. It's going to be a fun ride. All right, let's jump right into our first section, the science of movement. If we're going to understand this incredible machine of ours, we've got to get to know the two sciences that basically wrote the rulebook. Okay, so let's get these two straight. You've got kinesiology and biomechanics. The easiest way to think about it is this. Kinesiology is like the user manual for your body. It tells you about all the parts, the muscles, the bones, the joints, and how they're all supposed to work together. Biomechanics, that's the physics engine. It's all about the forces at play, things like gravity and the actual power your muscles generate that make you move. So one is the what, the machinery, and the other is the how, the power that runs it. So you might be thinking, why do I need to know this? Well, it's actually super practical. Understanding how we move helps us do, well, everything better. Yeah, for sure, it helps pro athletes break world records, but it's also huge for everyday life. It's how we learn to prevent those annoying injuries, how physical therapists help us recover faster, and even how to fix our posture from slouching at a desk all day. It really is all about making our own personal machine run as smoothly and safely as it possibly can. Okay, let's dive a bit deeper now into biomechanics. Because here's the cool part. Every single move you make, whether it's a super powerful punch or just, walking to the kitchen, it's all secretly being controlled by these invisible, universal laws of physics. First one up, the principle of stability. And this is basically the science of not falling over. Think about a sumo wrestler. They get into that super wide, low stance for a reason. They are intentionally widening their base and dropping their center of mass. And why do they do that? Simple physics. The wider your base and the lower your center of gravity, the more stable you are. It just makes you way, way harder to push around. It's pure physics, right there on the mat. All right, next up is torque. Now, I know that word sounds like it's straight out of a physics textbook, but trust me, you use it constantly. Torque is really just a fancy word for a rotational force. The best example? A bicycle pedal. When you push down on that pedal, you're applying torque. That's the force that causes the whole crank to rotate and makes the wheels go round. See? Super simple when you think about it. And then, of course, there's the big one, Newton's third law. The principle of reaction. You've heard this a million times. For every action, there's an equal and opposite reaction. Now, think about how a runner moves. It's kind of wild, but they aren't pulling themselves forward. What they're really doing is pushing the ground backwards with their feet. And in reaction to that push, the ground pushes them forward. That action-reaction is literally the foundation of how we walk, run, and jump. All right, so we've got some of these physical rules under our belt. Now let's tackle another really key idea in biomechanics, and it's all about telling the difference between what causes a movement and just describing the movement itself. And this leads us to two more K words, kinetics and kinematics. Just remember this. Kinetics is the why. It's the study of the forces that make something move. We're talking muscle contractions, gravity, friction, all that stuff. Kinematics, on the other hand, is the how. It doesn't care about the forces. It just describes the motion. How fast is it going? What path is it taking? What's the distance? One's the cause, the other's the effect. Yeah, this quote really nails it. Let's use an example. Say a javelin throw. The kinetics part is all about the why. It's that explosive force coming from the athlete's shoulder and arm that sends the javelin flying. The kinematics is the how. It's just describing the beautiful arc the javelin makes, how fast it's going, and how far it travels. See the difference? Cause and result. Okay, so if we're going to talk about all this stuff, like pros, we need to learn the language. There's a specific vocabulary for describing how our bodies move, and the great news is, most of it comes in these really simple pairs of opposites. It's easier than you think. Let's start with the most basic pair of all, flexion and extension. Flexion just means you're bending a joint, decreasing the angle. The classic example is a bicep curl. You're closing the angle at your elbow. And extension is, you guessed it, the exact opposite. You're increasing the angle, straightening that arm back out. That's it. Bend and straighten. Flexion and extension. Okay, next pair.
Abduction and adduction. There's a super easy way to remember these. Think about the word abduct, like aliens abducting someone. It means to take away, right? So abduction is moving a limb away from the midline of your body. And adduction, well, you're adding the limb back to your body. So raising your arms out to the side like you're making a T, that's abduction. Bringing them back in, that's adduction.
All right, let's fire through 3 more quick ones. Rotation, well, it's exactly what it sounds like. Turning a bone around its axis. Like when you shake your head no. Easy. Now for your forearm, there are 2 cool ones. Supination is when you rotate it so your palm faces up, like you're holding a bowl of soup. Get it? Supination, soup. And its opposite is pronation, turning your palm to face down, like when you're typing or playing the piano.
Okay, we're at our final section, and this is where we're going to put everything together. This is the big blueprint. It turns out that every single complex movement we've talked about, all of them, can be neatly organized into 3 invisible, imaginary planes that slice right through our body.
So check this out. It really does all click into place here. Imagine 3 giant invisible sheets of glass passing through you. First, the sagittal plane. This one cuts you right down the middle into left and right halves. Pretty much any forward and backward movement, like all that flexion and extension we talked about, running, doing squats, that happens in the sagittal plane. Next, the frontal plane. This one divides you into a front half and a back half. This is the home of side-to-side movements, all that abduction and adduction. Think jumping jacks or side lunges. And finally, the transverse plane. This one slices you horizontally into a top and a bottom half. And this, you guessed it, is where all the rotational stuff happens. A golf swing, a baseball pitch, a pirouette. It's amazing, right? Every single thing we do fits neatly into one of these 3 planes.
So there you have it. Your body isn't just a body, it's an absolute masterpiece of engineering and physics, designed for incredible, complex motion. What we did today was just flip through the first few pages of its user manual. So the real question, the one I'll leave you with, is this. Now that you know a little bit more about how your machine works, what are you going to do to make it run even better?